Hello, good afternoon to all of you. Welcome back. Shall we then resume and open for our last session of IX Forum? We have Professor Mendes from Anatel and Professor Rodrigo Porto from UFC. They are going to highlight the TVWS, TV White Space. Good afternoon. I am Zorello from nick.br. The goal today is to introduce to the technical committee a project which has been developed by several players addressing the best way to deploy the idle spectrum for radio diffusion in those more remote areas. And remote areas, they have internet access issues. There were great talks addressing this kind of issues, and also there is a radio diffusion spectrum issues. The TV white spaces, the goal is to deploy the white spaces spectrum to deliver internet services. How can we make the best use of such a spectrum? This is this session's agenda, participants, motivation, the TVWS solution, our goals, and how about the regulatory framework. The White Space TV is a project conducted by nick.br in partnership with the UK government. FCDO, the Foreign Commonwealth Development Office, is behind the project with nick.br support and coordination. We have some agencies participating from a modulation and radio technology. We have the Telco National Institute in Anatel, being represented here today by Mr. Luciano, and the last development support is being developed by the Federal University of the State of Ceará. Professor Porto, he is one of the coordinators at UFC. This is a joint effort supported by Anatel. We understand that we have to expand the connectivity between households from rural, remote, and difficult access areas to allow new communication techniques that can be better exploited by TVWS. This is not a new topic. TVWS is being deployed in some regions of the world with kind of older technologies. And now, thanks to cognitive radio and new technologies that can better deploy and explore some important aspects which are part of this project. We also have to make available another access way, in addition to optical fibers, radio, licensed frequency. And the goal is to allow an additional technology that will be helpful to access remote areas. And in addition, we have to check and understand the impact of the regulatory framework in the use of TVWS in Brazil. We are still depending on 2 publications, and let's see what is about to come. With that, there is enough room to develop this new regulation, and how will that impact TVWS in Brazil? TVWS deploys in a secondary mode a idle radio diffusion in remote and rural areas. Primary access, they come from radios. However, they do not occupy all channels. If you consider the geographic area of the Brazilian territory, where we may divide the territory in municipalities with a number of channels for radio diffusion. Next door, considering a certain distance, the same channels can be applied. The new deployed modulation techniques, they guarantee a lower interference in adjacent channels that may be deployed to allow a better usage of the available spectrum. It allows multiple operators to work in the same region without any interference. Primary services, they are protected. This is the four. And there is also a single database that can be operated for more than one administrator. Database is to have a free channel allocation for a certain service which should be deployed in a certain place. How about the goals of the project? To establish regulatory constraints, collaborate with Anatel to promote support to the coexistent secondary networks, lab tests and field tests, new techniques, digital communication to explore TVWS, to assess functionality and performance of a certain database that will allow technical references, national and international regulation, and dissemination of outcomes throughout publications and congresses. This regulatory act was introduced by October 2021 with different radio frequency ranges, VHF and UHF, to deploy TVWS. Professor Luciano will go into details about that. What is still pending are 2 other regulatory acts that will encompass primary operators, and they have a priority in the use of those channels. We still have to define and make liable carriers that are responsible for database geolocation to protect primary carriers. That's it for now, my introduction, and I will hand over to Professor Luciano, who will go on with the presentation. Thank you, Gilberto, for the invitation and for your introduction. I'm so honored to be here today and to introduce our project and what we have been achieving at Anatel. How can we make the best use of that space, internet space, to take internet access to remote areas? Anatel is a learning and research institute with the main focus in engineering. We are in the market for over 57 years. We work on human resources, technology, market, technology transfer. This is our campus, which is located around 250 kilometers from São Paulo, capital. Anatel has always been a pioneer institution. In 2013, we realized that digital networks were emerging, and initial propositions wouldn't include some key aspects to our society, such as agribusiness, which requires additional information, but yet they are not able to collect real-time information. We were responsible for the Brazil 6G project that by 2030 will raise a debate about Brazil and the standardization. 5G will not meet all necessary demands, and what should 6G present to be able to cope with additional demands? As my colleague said, this is a joint effort between the UFC, Inatel, NIC.br, the UK Embassy. They are fostering incentives to help the project. How about our goals? We want to improve connectivity, broadband connectivity to remote and rural areas. 4G was a network raised to be effective in cities. 4G doesn't have a great coverage range, and broadband cannot be taken everywhere. That represents constraints, especially in the field and urban areas. We haven't got enough network to become that sustainable. 5G, they came to stay. The 16 release will be briefly issued. With all those latest releases, we have MAC and physical layers network for urban areas connectivity coverage. There is not a long reach aspect to provide connectivity to remote areas. So the TVWS allows us to have lower costs and yet allow connectivities to broadband in urban areas. That is similar to SM, and with much higher rates in the UHF range, you are able to disseminate that connectivity in a long run. There is a radio diffuser which has not implemented that network. There is no broadcaster, and the spectrum is at halt. So the idea is to take that transmission to end users. Telefónica, the Brazilian telco, has conducted a research addressing the populational distribution. AI supported this research, and here we can tell exactly where people are. In the middle graph, this is a 2G coverage. We consider those plotted regions not being served by internet coverage, and then 3G or 4G coverage. And far to the right, we have television stations plotted all over the country. A recent report pointed out that around 5.5% of our population, they haven't got internet access, and that amounts somewhat to 10 million inhabitants. A prototype was developed 100% based on CDR. That is a complete receptor with 2 layers. It operates over a Intel computational-based platform that has been developed based on a software. Today, we use the linked radio, and radios, they are cheaper. As we work with 2 interfaces, XTRX and blended RAF, they are cheap platforms, and in case we do need much higher process acceleration, then a hardware can be used. Over here, you'll be able to see how the technology moves. This network deploys cognitive radio to explore those spectrums which are not in use in those more remote areas. Such a spectrum is idle in a remote area, and to make the best use of this spectrum, yes, unfortunately, we could not translate this little piece because there was a audio overlay. Yes, please, if you could mute the computer audio, we can keep on translating. 24 megahertz spectrum, 4 channels. This is the max broadband. This is on-demand resource allocation, similarly to a Wi-Fi, as we have to transfer data. Allocation may be done in a 4 blocks of 25 megahertz, of 6 megahertz actually. Those will sum 24, and such a network has to be wise enough to release the spectrum. Database access will be able to tell us priorly if that channel is being occupied or not. But we have to confirm such an information in the field for 2 reasons. One, if there are propagation effects that are considered to be realized over the softwares, or an area that has been discovered without the presence of the radio diffuser. And the second example is in case you have a pirate TV. This lower signal is detected by the radio and keep on exploring adjacent bands. You drop the release, but you still do not compromise the primary sensor. Here, GFDM signal is a more modern modulation, and here there is no signal interference or whatsoever. If we move to FDI, which is the oldest modulation, then you may bump into some issues. So this space is not compatible to the legacy systems if you apply an older modulation. But if you deploy state-of-art in digital communication, we may make that feasible with no interference, even though we deploy adjacent channels. That's it for now. Thank you for the time and opportunity, and I give the floor back to Professor Rodrigues.
Good afternoon, everyone. First of all, I would like to thank the organizers and the invitation of Milton Gilberto. It's great to be here, my first time, very interesting. And I want to thank partners Nick, Natal, the British Embassy. A very interesting project. Milton Gilberto and Luciano showed us a great introduction of the topic. I'd like to add specifically on this part of the system, which is the database. Well, first of all, to explain why I'm here. Well, I started to research this over 10 years ago, right after the digitalization of our TV. It became clear that we would have definitely a cash cow, which would be the VHF band of UHF. And what I mean about that cash cow, because they're favorable for streaming. So the idea to use this idle spectrum just seemed obvious. But as you can tell, it takes long. From the moment the research study started when we went digital with our TV, 2008, 2009, it's been 10 years. And now we're starting to see to actually build momentum with the regulation of Anatel and all the tests that are the ones that Luciano mentioned. That's what I'm here. So our university already has a track record on the topic. So many other points were said about digital inclusion, about migration of analog TV, and definitely as a last point, since this is used in a secondary regimen, it translates into a reduction of cost of capital when it comes to not having many cost of acquisitions and use of the spectrum. The database on this bottom part, there is a core part of the gear. It will link the impositions from the regulator that will protect the owner of the spectrum, the TV networks, for instance, which we call primary users, and will link these demands and these restrictions of the regulator with the capacity of the transmitting radio. So both will have that as input of the database, and then there is a reading so that we know exactly in that specific GPS spot which channels are available. That is core, that links these two ends from regulator to technology of radio transmission. And this database, the way we have, since it organizes the use of the spectrum, since it's used in a dynamic fashion, in a dynamic base, and in a secondary basis, so you need to have that coordinated, and we have the incumbents being protected in terms of the licensees, but also avoiding interference from the secondary ones. So from many operators that can have interest in simultaneous use of many of the channels available in that location. So that's the role. And the starting point is to use statistical models that are very reliable and that have been validated in the international literature, where there can be used, as Luciano just mentioned, a technology of censoring of the spectrum to enhance the statistical model. So if you just use the static database, it works, but you need to protect. So it needs to be broad. So statistically speaking, you can reduce probability of causing interference on the primary user. With the censoring, we're able to have a greater granularity there. So it complements to the dynamic censoring of the spectrum of the full radius, and definitely you need to have an entity to manage, not Anatel, the agency that has outsourced this type of work to regulate the activity of providers, and that's also a point that is open in the regulation in terms of how this is worked, who will manage, so on and so forth. And right there on the diagram you can tell, I show you exactly the importance in terms of TV station locations, transmit antenna types, the characteristic of the signal transmission. The statistical model I told you takes into consideration these details, so there can be reliability. And finally, what are the contributions specifically of UFC, of our university, to development and demonstrate the database, something that had never been in Brazil done before, and this is definitely a first time. Adhering to international protocol, where we have RFC 7545 internationally accepted to adopt this database, a dialogue with a database of Anatel with as Mosaico that has that from the TV networks. And something that is quite new here is the use of blockchain to make it possible the use with the providers. We see this possibility, multiple providers at a regional, local level using this database. So blockchain comes at a great moment to organize and allow the safe operation to audit and distribute. So finally, to contribute to the whole regulatory framework, Brazil's Anatel's agency still needs some public consultation in terms of objective rules for coexistence between primary and secondary. Our project wants to contribute so that there can be a public consultation from Anatel and having a starting point from experiment that has a great basis to be provided, and that's a very interesting contribution so that Brazil can have faster access to this technology. And my last slide now, where we're at in the Federal University of Ceará, This is my email. Thank you very much. Have a great afternoon. Thank you, Professor Rodrigo, Professor Luciano. Thank you for your presentations. And the whole idea now is to open to questions and answers, to have a conversation with you about this technology, about what was just presented. Does anybody have any question? Would you like to use the microphone? I don't think so. I thought he wanted to. Okay. Well, actually, there are two things. Maybe I didn't get the beginning. Maybe I missed out on some information. But what is the capacity of transmission that the service can provide? And also, how would that be explored? I mean, would it be multiple companies to be able to explore it? And as we said, with many companies competing and requesting the use of certain frequency in a location, just want to understand a bit more about it. What would be the next step when it comes to harnessing? Well, the model that we see is the idea of have regional ISPs that wants to offer a service of productivity. So it goes there, it buys, and then you are able to have this coverage. So this is something that, I mean, in terms of a license, that's just from exploring. So it submits this to Anatel, and then as Professor Rodrigo, this will take to the provider a band to be used. In terms of the capacity, we did a field test before regulation using 6 + 6 watts for the antennas, and we were able to get 50 kilometers with 100 megabytes per second. So this was in Santa Rita do Sapucaí all the way to Campos Jordão, where it's 106.2 kilometers, straight line, hilly region. Those who know the region are familiar. So this was 100 kilometers, and we have this frequency. So what's the problem now with the regulation? Regulation today went to 1 watts per peak per channel with antenna delivery. So the average power you're able to have a modulation with multiple will be about something under that. So we're talking about 1 per antenna. So we can work on it to have a better reach, but that's our challenge. This will definitely reduce our capacity if that's the case, but we still have not gotten to it to understand the extent to which that would be. So we're installing this antennas now again, asking for a license to get the use to be able to measure and see what would be the capacity because of the current restriction of the power to be used. Thank you, Professor. Do you have any other question? Well, I have a few. Professor Rodrigo, as other countries that use this technology, are there? Yes. The presentation that I made available showed a slide with a table with some worldwide experiences that we've seen. So this is no new technology, although it's first time in Brazil. And this is the case, for instance, in the UK, which is a country that has been quite advanced. Why do they use this technology? To be able to meet the need of some niches, like in a standalone island, few people, where the carrier won't get there because of no economic interest. So you're able to have that right there. In some advanced countries, you have a use specifically on these spots, where for healthcare, using something of low cost so that there is no cost with a mobile operator. In countries, third world countries as India, so on and so forth. So you see this type of spotted applications. In Brazil, I believe we have a market. So if we think about the state of Ceará, which would be a natural candidate to that, Fortaleza definitely has a good provision of broadband, and also the coast because of tourism. But when you go inward into the state where we have 4 to 5 million people. The demographic density is very low, spread out in villages and cities. So because it's spread out, that's why it makes it a challenge economically for a provider that just looks at the value for money. And also with other situations in Brazil, as we have with Center-West, with agriculture, as Luciano has mentioned, definitely there's a market out there. We see this as an interesting complement that is important when it comes to digital inclusion in Brazil. There can be the best white space case of TV in Brazil if we're able to carry on and as long as Anatel can speed up the regulation process. Thank you. Professor, would it be for free the use of these frequency bands? You talked a bit about that in your presentation. Could you explain a bit more about that? No, I don't think so. I don't know if you're buying a license, a scientific license, but you have to pay for it. Even for a scientific experiment, definitely you got to pay for it. Definitely it won't be for free, but nothing comparable when you have the 5G auction. There are 50 billion reais. These figures that you just have the big players taking part. There is a provider of Ceará that was able to raise 1 billion to get into it. That's exactly not where we're at. We have the primary, the secondary. So we can say that we're talking about things that can perfectly get into the business plan of a regional provider of small to medium size. So I don't see that as a hurdle. And specifically when it comes to Brazil and compared to these countries where there's already the use, we have a scalability that's interesting. We can use that with technology. That is something that still has to be taken into consideration when we talk about specific plans for Brazil and taking into consideration this big market that has not been assisted. And to complement that, I mean, around the world, we see applications working with one provider exploring that specific spot. And Brazil is quite different. It's a big country with many providers. Definitely will want to see this. And that's why it's important to have this database. I mean, it's being developed based on the format. I mean, to have this in Brazil. I'm afraid we ran out of time. Professor Luciano, I don't know if you would like to give your final remarks. I would just want to again thank their organization. I think this initiative is great to be able to take this further on, and there's a big challenge. This regulation, can it make it feasible, this use? So we are fighting against the 1 watt limitation, and I count on you for this support. Professor Rodrigo, I'd just like to thank you all. Interesting experience, and I'd like to just reinforce Luciano's words. I don't know if we have the Anatel agency delegation. If you're here, that is really my claim here to you, to accelerate the regulation so that we can close the gap of a digital division in Brazil. Okay, thank you very much to bring to us your project. Thank you very much. Thank you very much. And now we will talk about IPv6 challenges for deployment in a campus network. I'd like to invite Eduardo Tretel from Unicamp. Please, you may take the floor. Thank you very much, and I'd like to thank Nick for your time. And to everyone who's here with us, I'm Eduardo Tretel, and I am the coordinator of IT security for the University of Campinas. And the whole idea of this presentation today is to have a whole track record of what we have developed with our team, and even before, what the team has been doing the last 12 years to implement IPv6 in our campus network. And those are the challenges that many here have shared, are well aware of, and some of the details that might be a bit different because of the nature of our business, which is higher education and research. And there are some specifics to it because of the diversity, because of also some transparency of the public sector, and on the other hand, some advantages because it's an agency very close to research and development. We have greater fostering of new ideas, and that somehow can help or has helped over the years to accelerate the process. So here, just a quick schedule of how the campus is for those who don't know of our network, so you can understand the size of and how many campuses we have and what that brings in terms of the demand of a protocol. A quick timeline of what has been done in the last few years and the focus, quick, related to IT security in terms of IPv6, and finally, to conclude, a review of what has to be done and a good process to carry on, and what are the approaches to face the challenge. So thinking about this, universities are public universities of the state of São Paulo. Well, we have a university that is a 56-year university, and we celebrate this with much joy that we have just been around for a bit over 50 years, but with all our achievements, it's quite significant for all this. So that's why Unicamp is ranked as the 3 top ones in Latin America. So we have 6 campuses around in Campinas. I mean, thinking about it. So the other one for Campinas, we have the vocational school, we have Paulínia R&D Center, Limeiras, and the University of Dentistry in Piracicaba. They're very close, that they vary from 30 to 80 kilometers. And here we have a few data when it comes to students, professors, and also, we have a graduate course, especially in healthcare. There are 4 hospitals also, where 2 are in the Campinas campi. 1 specifically to women's health, and the other 2, which are Piracicaba and Sumaré, but are managed by Unicamp. And together there are here the number of services that are able to deliver. So we're talking about 800,000 appointments. So to have this network in terms of continuity of business. And here we have a diagram of the topology of the network and some data of how it is and its size. From the typology side, we have 2 layers, as you can tell. The first one at the top, which is one of internet connection mixed with aggregation. And the bottom one, with the darker blue, the servers, which is the distribution layer, where the units and this type of thing, the hospital, get connected. You'll see there are 6, and I will ask you to realize in terms of the process of addressing. So here we have some data. Unicamp is an independent one where we have 60,000 users, from visitors, permanent community, which we consider students, professors, employees. We have around 20,000 devices on cable network. We have 30,000 mobile devices, including a wide range of sensors, and also Wi-Fi network that crosses the campus, that has now 900 access points, under centralized management of our team, and also on our remote zones. And all of this gives us a good clue of the complexity of the network that we must manage. And additionally, we have to take into consideration the remote and campus networks. And what is the aggregator in terms of complexity? The IT team in charge for each unit is decentralized, so each college has their own IT team, and they are autonomous within the way they are set to go after their solutions of ICT. And that's something that is being converging over time, but it's something that in the past, especially when we got started with IPv6 implementation, that was quite decentralized. And this brings one more element that is quite a challenge to be able to apply single policy, one protocol, and it's not the case with IPv6.
Here an overview of our external connections, and the main one is the RNP provider, Unicamp, which is a university in the region of Campinas city, that is an area very rich in research and development. RNP in Campinas, and we also have a POPSP throughout the .br digital, that is a physical connectivity to São Paulo. That is an aggregation, a point for the RedNASP, that is a project of FAPESP, and with the ix.br in São Paulo. And additionally, we have a peering with Google, Amazon, Facebook, router servers of ix.br. In addition, we host a PIX throughout a transportation that is done with the involvement of RNP network. We started back in 2010, 11. Those were our first initiatives. Colleagues from LACNIC, similarly to us, we started at a time where we were feeling quite comfortable. It was a different scenario, very much different from the one we have today. To be able to implement IPv6 over a network, that is a necessity nowadays. However, back then, IPv6 was more an academic approach than a need or a must, as it is nowadays. And for that, we created some working group to develop this task force in partnership with nic.br. some IPv6 prefixes were allocated to an IS 5310187. And thanks to this lovely partnership with NIC.br, we were able to perform a capacity building on site at NIC.br's office back then, 2011, when our first initiatives started. As we were already an AS, the V6 block allocation was allowed /32. And after this deployment, first initiatives to implement more effectively the protocol started. We had a double pile on servers. Unicamp was invited to participate at the World IPv6 launch, which was in 2012. Those were our first initiatives, devices of backbone that yet would not cope fully with IPv6. Now, backbones, they can cope with IPv6. They were not IPv6 ready. There were several constraints and limitations to have a full deployment and allow optimum performance of IPv6 throughout the backbones. The idea was to start right from scratch. Here a summary of the steps addressing submission of IPv6 implementation. As of /32, which was the institutional part of the infrastructure. /32 breaks down in 8/35, the first /35 allocated for infrastructure purpose. All others, they were allocated one for each NOT. And still, within future perspectives, you may say that routing knots, they may keep growing. That's a fact, indeed. So out of each one of the knots, we get the first /36 is still within /35 to knot allocation, and we save another one to break that knot down in the future. In the 36, we have to understand how to refer to those units that encompass knots. 90 to, maybe took 50 years to reach 90 units. Let's then allocate 6 bytes for the unit that will represent 42 units to each one of the blocks. Each knot may allocate 64 units. That process is repeated again and again. The first 48 is allocated to each one of the units, and all the leftovers, they are kept for future extension. In case we still find it necessary to keep growing, we may save that for future needs. Or if we are talking about an academy, university, which increases in size, you have to save some space to fulfill future demands. The unit has to repeat that internally, especially as we are dealing with best practices, and allocation has to be well understood, segmented in accordance to the network needs. Of course, that we have to comply with thresholds. We cannot segment anything greater than /64 to any users. 2013 and 14 a new backbone. Now this one can support a IPv6 fully. We have a double PIO stack for router purpose. We close the BGP peers sessions in IPv6. We have a functional backbone in IPv6. Next, basic DNS servers. That was in 15 and 2016. Any services hosted at Unicamp would be coordinated and served by basic IPv6 services, 2017 and 2018. Here we have to highlight our participation as assistants after 10 years of initiative of IPv6.br. I forgot mentioning that back in 2013 there was an additional initiative together with NIC.br to make capable all technicians that work in the research, development, and learning area. And a second group participated in 2018. First group, 50 participants, the second one, 55, a total of 90 units, and we were able to have at least one technician per unit that underwent that workshop to improve skills and to replicate and multiply learnings after the session. Now, 2019, 2020, VoIP and Wi-Fi in double PIO stack. Now we see an opportunity for IPv4 addresses, which we are running short of IPv4 addresses since the beginning of the 90s. Our internet connection was available in the academy, and some large blocks by DHCP were offered throughout IPv4. That was not enough. Some other blocks were requested, such as /19/19. But yet, we didn't have enough. We were running out of additional addresses. And as we have a great IPs availability, we decided since the very beginning to leverage public IPs networks. So those who work in administration, professors, directors, they get a public IPv4 to work as routers inside the universities, avoiding NAT 44 as much as possible. And whenever possible, those units that have IPv6 already, we prioritize devices that run under IPv6 and not IPv4, and to a double stack. And we introduced double stack in the Wi-Fi network, but under some sacrifice of the public network, as we had to work on a private addresses. CGNet is not common, but rather just NAT 44 if we have to route that connectivity to external traffic. And alternatively, we use the IPv4. No, and internally we use 10064. That represents a growth in the traffic of IPv6. All charts, they are in double stacks. The dark plotted areas, they represent V6, the light color V4, and one overlaying the other one. we see that there is a increase in the peaks displayed by the graphic, by the charts, I mean. And we had reactivated the double stack in the beginning of this year. And we have some comparisons with the Antigon traffic, which does not take place globally because Wi-Fi has IPv6 consultants, and that consultancy of IPv6 in 2021, and with the pandemics, there is an increase in external access traffic. People, they were doing home office, and there was an urgency for more access. We bump into a problem which was internet growth, diversity in the routers and the backbone devices available. They can no longer cope with the demand. We face instability, boxes, they cannot change and find new routes, and to preserve stability, especially in the Wi-Fi network, which is more sensitive in terms of latency and so on, we deactivate double stack. This is an option, and this is the first step backwards. We end up investing on exchanging equipment, devices. We are able to balance the V6 double stack since March this year. This chart shows now those dark green lines on the chart on the left, in the chart on the left, because now the university campus is going back to normality and IPv6 traffic is increased. We participated at the 9 IPv6 LACNIC challenge. That was a contest, and we were awarded in first place by thanks to our team and on behalf of Unicamp University. Alternatively, this year we delivered another IPv6 service platform that is a net 64 institutional solution. We still see some constraints in this net 64 institutional solution, which allows that DNS 64 resolution matching the net 64. That is a lab that supports IPv6 if we just have connections coming out, but there is no traffic once the connection starts on the IPv6 side. It's exactly the opposite, allowing the design of some situations where a purely V6 network releases the V4 pressure, and it releases the need to go for maybe a NAT 64 or to avoid, whenever possible, a CGNAT. So far, we survived without a CGNAT, and now that we are purely going to the IPv6, it doesn't make any sense to embrace CGNAT after so long. This is a well-known solution, and that is a combination of a DNS 64 vector in combination with a translator NAT64. The V6 network end users, they inquire servers and they ask for a quadruple A. If that quadruple A is valid, they can submit that to other clients such as Google, Amazon. But let's say our Unicamp web sector has no quadruple A. So a quadruple A has to be synthesized, encapsulated within V6/96. And the route will be a NAT64. The translator will submit IPv4 traffic, wait for a response, re-encapsulate it, and gets back to the natural flow. IPv6 safety, how about that? We have always worked with a public IPv. We were concerned about filtering traffic, avoiding spoofing, avoiding open recursive manners, because we have a device that is in the Universe Lab or in the DIMS office. And as Professor Lancier mentioned yesterday, we have a false illusion that we are protected behind a net. That's why we have to be double careful. But in addition to that, and considering the network size, we want to know what is going through our network. And our safety incidents response, the CSIRT team performed a data flow analysis. That was an endeavor conducted with CSIRT, with CERT.br, where we collect flows, we throw them to the backbone equipments, we run a script for further analysis and reports. This is a amplification report showing V4, V6. All cases are shown here. Reports may be customized. There are some classic examples such as stop talkers, open recursives, amplification, UDP systems, botnets, and another example is a report. We haven't got time to go into detail, so I would like to invite you to visit those two links where you'll be able to find the PDF presentation of CSIRT Unicamp during the 4th Fórum CERT.br and CSIRT in 2015, and then a video showing the use of dealing and management incidents. Challenges, the main challenge is most content is stored at Unicamp Cloud with no IPv6 support. We feel so ashamed to say so, but this is a consequence of a bet that we made in the past to use CloudStack as the main orchestrator, and CloudStack had in the roadmap a chance to give support to IPv6, but we had to migrate to VMware vCloud. The goal is to expand the cloud, and together with the expansion of the cloud, we have to turn that into an IPv6 support. We have legacy systems. Some of those are so old. Some have their codified IP's address, IPv4, codified over the codes, and access control use with no IPv6 support. We also see another challenge, which is to try to develop a purely IPv6 network. But there are some obstacles for that. Mobile customers who use Android and have no IPv6 support, and Android as a whole hasn't got a DHCP support. So a Slack implementation has to be done. And last but not least important, we have to skill people throughout some capacity building workshops like those that we gave some years ago, but people have left university, they have to be readapt, reskilled, and we have to go into details about taking IPv6 to units to our end users, such as the universities.
And that's more concentrated on the backbone. And to complete the daily traffic on the backbone, here the one that links the units and the internet, it's not the output traffic, it's our internal one. So this is a proportion of pretty much 10% of the IPv6. And the trend is to have this grow, because the big limiting is that there isn't much traffic because there isn't that much internal content, which is majorly hosted on an environment that doesn't have IPv6. Once we do get our portal IPv6, we'll have quite a quick increase here. So to conclude, I'd like to thank Nick for the partnership over the years, and to give the opportunity for us to get a deeper partnership with Unicamp's partnership and knowledge, and to be able to host an event, a week, a Nick BR event. We have started talking about that, then the pandemic came around, but that's something we can go back to it. So I want to thank my team that I lead, and that has been over the years working with this, a pioneering work. I'd like to thank the members of the work group that are not from our team, but are other universities that have supported us. And here to be here with Professor Godoy from the Applied Sciences of Unicamp. And I know many of you know him. He is a big advocate of IPv6. And finally, the ICT community of Unicamp, with administrators and colleagues that give us support on a day-to-day. And thank you all for your time, presence, and I'd like to make myself available with Nokia Unicamp, our CSIRT, security at unicamp.br, and also the work group IPv6, somebody that would like to share anything. Once again, thank you. And I apologize for going over my time. Thank you, Professor Eduardo. Is there any question or any comment on his presentation? I don't think so. Thank you, Eduardo. Give you a hand. I'd like to invite on stage Tatiana Figueiredo from Datacom, who will be talking about load balancing traffic and transport networks using link aggregation. Let's remind you that everything is on our website. For those who are working remotely, you can download your PDFs and you can therefore check on all presentations. Hello, good afternoon, everyone. It's an honor to be here to be talking to you about a topic that is present in the life of providers, which is load balancing traffic using link aggregation. Do I look uptight? I know it is to talk with such an experienced audience to tell you a bit about who I am. I can't see from here, but in any case, So I've been working in the telco market for over 15 years, always in training and support. Now I work as a trainer at Datacom. And the reason why I brought this topic was because of the questions that we get from our clients and who we talk to on a daily basis, from the behavior of a link aggregation until this type of thing. I mean, and as we talk about it, I mean, one of the motivators, let me see how I can see this, is about the diversity of the application of the services through demands, over the top, where we can see videos in a moment that we desire, and thinking about the specific plan with that supplier, and also the growth of e-commerce. I don't know about you, but I've developed nearly a compulsion for buying online. We buy everything there thanks to what recently happened to us in the pandemic. And another point, are more devices connected? Smartphones, tablets, all at home, but we have more of them. Isn't that right? Do you agree? Is that right or not? Come on. Yeah? An Internet of Things with sensors, the coffee maker. I mean, to turn on a light, all that brings us traffic. Online, I mean, who hasn't done a live before? Many people. Can raise your hand. I mean, it can be maybe an undergraduate course, where at the time you didn't have in-person classes, the small ones. Many times we brought them in-house, and we had to adapt them to the classes and also to entertain them all so that we could work on a day-to-day. And home office, many companies adopted that as a practice because of quality of life. Not everybody is able to, but it's a reality. So this traffic that before was present in the corporate world went into our homes. And the exponential increase of number of users. Everybody. I mean, I've heard a lot of help. People needing to really see how Tati has all this demand of traffic because there's a lot of people there. And the constant need of being the social media, teams for meetings here and there, so on and so forth. Well, and as providers and manufacturers, because we're here to take technology, connectivity, because of everything we're doing now. And all of this, I mean, doesn't allow us to reduce social inequality in the companies. How many of you have heard one of these names? Many call it link aggregation, lag bonding. Each has their own name for it. And it's great when you're there trying to help and the person comes with another name. You start talking and you're like, what is that? Give me some detail, and next thing you'll see, it's link aggregation. And why link aggregation? The whole idea is to have the efficient use of our network, to be able to use the resources, increasing capacity without losing any quality, despite the gaps of equipment and also the jumps we have from an interface of 10, 25, 40, and 100 gigabytes. So if we talk a bit about link aggregation, what is it? Some people have worked with it. Have you all worked with link aggregation? Okay, let me see, just 5 hands. Not much. Is that right? It's everybody then. Oh, okay, Tiago. Oh, everybody has worked with link aggregation. Okay, great. So link aggregation, what is it? Is aggregating interfaces, physical, and logic, so that I'm able, through these channels, be able to go through my traffic. And it brings, it offers, let me see if I can point here, the links that are redundant. So think about where we have, this will be sent to the other interface, and when you're back, you will have the flows from 1, 2, 3 in terms of interface. And then we have the increase of band 1 gigabytes 10, and then when we have this, what do we have? 2. It depends on which one we're talking about. So aggregation goes through the same speed port. And then what do we have? A better application of the protocols based on convergence. It can be L2, L3, MPLS. Got too excited here, just to hit my controller here. But anyway, and also in terms of performance, because when it comes to convergence, I still have traffic going that way. I don't need to have all my traffic heading one way and to have the convergence, because I have an aggregation. And all the services related to it, be it IPv4, IPv6, access list, MPLS, routing, they will all be made based on the aggregation. We no longer have interface. And here I have an example of our physical interfaces based on a logic and using groups of aggregation per device. I can have a link aggregation or more link aggregation in one single box, and they can, depending on it, work with active ports or standby or inactive, depending on the manufacturer. So there are two types. We have the static, where we insert the information, what is the aggregated interface, and the dynamic, as it's called by LACP protocol, that allows us to establish the aggregation. When it comes to balancing, the flows that will get this balance, I would call it, within the interface. We always do what? The balancing of flows, not of the packages, because that can bring problems when it comes to coordinating and getting the performance of the equipment. And getting a bit into link aggregation, static and dynamic. I have a table here. The idea is not to read it all out, but just to give you some material so that you can go ahead and check yourselves. This is already on Nick's website. So here we have the static and dynamic, which is LACP. We have the control and a grouping that is automatic. You say, what does that mean? With LACP and also the dynamic balancing, I'll only aggregate the interface if I'm able to find the protocol on the other side. So I'll have an equipment that will send a message of control, which is a PD1, and then on the other one will say, okay, I have LACP. So then you have the aggregation. When it comes to the way it is, you have with just one single one, and in the dynamic, the active and the passive. In terms of speed of interface, in terms of everything, in terms of safety, to static, just the interface, you see it, and then you can get this done. So if I look and interlink with a long interface, the aggregation will also go up because I have no control different from the dynamic. To really be able to identify the protocol on the other side. Consequently, it will show connection mistakes. So On static is more control. I can invert port 1 with 2. Odds and evens depending on the manufacturer, and while ACP is less likely. Going to the balancing mechanism, which is something everybody talks about. Something that really bothers me is that I have a traffic that is more polarized, more on one and less on the other. Is that true? Does that take place? Thank you for participating. And how should we do this? Because this is something that bothers everyone. Isn't that right? It's a classic. Oh, I have here 1 gigabyte to do this, but I have 700 on one interface and 300 on the other one. So I want to have a 50-50. Is that what we want to see? Yeah? Not necessarily to have a 60 or 30% is balanced. This depends on the flow I have, and they're not necessarily the same. But there are mechanisms that will do this following. They will check this flow, not the package, and they say what I have from A to B, and depending on the type of network I have, we'll go through the analysis, and the result of the full analysis will be an algorithm that will be running with a hash, and I'll have an interface of output, which is where the traffic is heading to. So if we're able to think about networks or a topology that is more based on layer 2, we are able to see everything in terms of mix, where we are able to see 1 or 2 or a combination, because when we see, we have a greater variability when it comes to MAC. When it's an L3 network, we're thinking about what? IP. Then I'll be using mechanisms and the criteria that will be applied of IP destination and origin, so that the traffic can be more smooth and balanced accordingly. Some manufacturers have the enhanced mode, which is the combination of MAC, IP, TCP, UDP ports, and labels for MPLS. These are the typical ones that we usually see on the vendors. Some have dynamic mode, which we'll see a bit later on, which I like to really say that it's a bit more aggressive balancing, because we'll always look into the actual load of the link so I can better distribute the flow. And then there is also round robin, which is a balancing per package. But here we have a resorting of the packages on RX once I get them. So I can even have some jam in terms of balancing based on package. So most work with flows. So I must have variability on my network, so I am able to choose, for instance, 2 interfaces and have a more pleasant, smooth, balanced, and not a polarized one. And if we get into enhanced, some call it the classic method. So getting back to it, it uses MAC, IP, TCP, UDP ports, and labels MPLS. So if we take a look at it, there are 3 flows: the blue, the black, and the orange. And with the result of hash, we're able to have them all here distributed. Is it well balanced? Yes, it is well balanced. Not because we have this interface here that means that the balance is not working. It might not be smooth as expected, but it is a balanced traffic. I consider a non-balanced traffic when there is the whole flow in one single interface and no other one. And why? Most likely because those traffics do not have variability. So they have origin and destinations that are the same. And to get this a bit better, there is the dynamic load balancing, DLB, that uses the criteria of enhanced, but the real analysis of the use of interfaces. So on the first example, we have here the green, the black, and the orange. And what did it do? It distributed, showing that these flows have variability that is pretty much at the same size. But then there is a longer flow right here, as you can see, the red one. What would it do? It will get into the algorithm and will resort it. So I have a longer flow. Previously it was this way, and then you have a longer flow right here, and then you get the green and the orange, and you distribute right here on the third interface. And then you'll take a look at it and say, great, these are pretty much doing well here at the same. But then here I have this black flow that is sitting all alone. Is it that way? Exactly. I will not break the orange or the green one to have a piece there to make this one resort the package on the other side. So, I mean, let me see how I'm doing with time and this type of thing. And now, thinking also about a factor which is MPLS in the networks. I mean, nobody uses MPLS. Is that right? Nobody, huh? I know. So what do we have with MPLS when we have link aggregation? Usually this traffic is polarized. That means is being used in one single interface. And why? Because I have a VPN with what's the origin, destination, so it won't change. I'll get this flow. I will be able to have the encapsulation and the other equipment, origin, destination, and it will be the same. So I don't have variability. And why should I then split? So this is where the point about, wait a second, back to my previous slide. Well, before carry on, when you talk about the traditional MPLS, here I have different colors. I don't know if you can see from there, but you can download the slides. And here it says 22, where it is transmitting 200 or 400. I can't really read from here, but it will get 600 megabytes in one single interface. And why does it? Why does it get from a single interface? Because the 23 up here is sending a single one to 22. So we'll always check this transmission because the one that's balancing is the one that is transmitting. So when we think about from 22 to 23, it will balance, and from 23 to 22, it will be balancing. And not necessarily will be symmetric in throughout the network. It will always be getting the flow, throw on the hash, and then have as a result an interface for output. And then we get into the FAT in MPLS network, where it comes to have a flow label inserted for each flow that equipment will receive. So here you have the orange, and it will add, other than the label of the infrastructure of the VPN, now you have also for FAT, which gives a greater variability for the traffic, allowing you to use more interface. But again, not necessarily it means that I will have a 50-50% balanced out traffic. It depends on the size of my traffic so that I'm able to manage the interface for output. And right here, when it comes to capturing a package using market apps, we're able to see that the label of the infrastructure, it can be LDP or SVP, the label of VPN, and the label for FAT. I mean, you can see the header is the same for all of them. Let's see how I'm doing with my time. Doing good. And now with the application in the same scenario of balancing the FAT, we have here in this equipment on 22, this one when 23 gets this flow, a balancing that is a bit more suitable.
They are not 50-50 because we are dealing with different VLANs and different amounts and values to each one of their flows. Some additional resources. I'm about to finish my presentation, which will allow some balance. We have the link aggregation with active and inactive ports or backup links. There is another option, which is the MC lag, which was widely discussed on Tuesday by our colleagues at the company where I work for. We have them under development. Equal cost multi-path protocol, layer 3, as long as they have similar costs, and MPLS traffic engineering. That's not quite as balanced, but they are also resources that we have available in our network, which will allow some balance. Here, my contact information. Thank you so much for your time, attention, and opportunity to be here with all of you today. Thank you. Thanks, Tiana. We have a few minutes left for your questions. Do you have the option to perform MPLS balance without FAT, just looking at the payload that is being transferred? Today, the traditional balancing methodology with the VPN, you parallelize it but for variability purpose, just with FART so far. Any additional comment? No? Thanks, Tatiana. Renata Fres from RNP. How to reach the best monitoring flow, syslog, and telemetry. Hello, good afternoon. I am Renata Freys. I'm part of RNP, and I'm also part of the Limelight project. What an honor to be here today to introduce our research and production project. A bit crazy though, but what is an Limelight? We are a academic traffic exchange point, and we have POPs in the US, in Brazil, Puerto Rico, Chile, Panama. We are supported by the NSF USA, but we have partnership with several academic networks with all countries. We have agreements with RNP, Clara, TNITS from South Africa, and a number of other institutions. And that's a very, very interesting project where our confidence layer is great. This is our network. It's rather complex. 100 gigabytes network. We have several underwater submarine links, earth links, and we have around 600 giga capacity between the Latin America, the US, and over 100 gigabytes to South Africa. How about our network? As a routers, we have a Juniper and a router free router. They are open source routers. We have a Blockade, Dell, Overflow, and Whitebox P4. You are going to see why that is so crucial to us. And a little bit about automation. We run SDN since 2014. For 8 years, we've been in that automated world, and the idea is to evolve more and more. As a southbound to talk to our equipments, OpenFlow 1.0, 1.3. And for automation, yet talking about automation, we have the data plan since 2021. Last year, that was under production, allowing a better monitoring to refine our INT monitoring. And we use an overflow for that case. But this is a giant network. Ours is small. How to monitor that? This is our solution. We have much more than that, believe me. We use SP, NetFlow, SFlow, Persona, telemetry from Juniper, and in-bands network telemetry, INT, which is our red flag, which is our flagship, I should say better, apologize. Let me talk about INT. This is the main novelty, probably to you. INT is an application developed via P4 that is a data plane, and it allows to place within each package in our network telemetry information. We insert metadata of the state of the network within each package. And then we can see what the package can see in our network. And it exports directly to the data plan. Does not even feel what's going on. Timestamp, queue buffer utilization, sequence number, and much more. INT, it is, you are going to have your server that is going to be totally normal and payload. The first switch and the software switch, and it will include metadata with telemetry of the NOT. And it's going to go through the network. If the next element is another TNT switch, it will accelerate metadata. If not, it will see that as if it would be any single package. INT 6 switch, where we are going to remove it, generate a report, and to send that to our IN collector. And then the package will be sent to the node destination. Going back about used techniques, I'm not going to go into details, just to let you know that we use much more than telemetry. Syslog, we use it because there is no way out, no other way out. Who has not used that? We use that in all equipments. And that is well used by other tools, Caracat, etc. SFlow, NetFlow. We may be able to see the top talkers, some weird DDoS attacks, etc. That's much more used in the academic network, and the idea of the persona is to have origin destination to test your network and to have a user perspective. Throughput, etc. We can do that in the academic network. We have different publics, anyone can use it. INT, I'm going to talk later about that, not going into details. JTI, Juniper telemetry. Of course, that we have other vendors telemetry, but as we use the Juniper, we are using the JTA. JTA is good because as this is quite expensive to CPU, with JTU it will go directly where the sensor is, that can be somewhere in your equipment without any burden to the control plane. We can make collections every 15 seconds. As I said, JTI, that is going to be very, very clear how it works. Here we have some cases that happened where we have all this monitoring, telemetry under production. This was an example, but one day our network showed some issues. We also have commercial traffic, commodities to some universities, academic institutions, and one day we got some complaints. It's everything so bad, and now it's back. First graph, SNP. Less than 5 gigabytes, interface 10 gigas, and the other output didn't see anything, but just 6 gigabytes. That's nothing. But that's not quite the case, isn't it? We got JPI that had just been implemented. Ten gigas for a few minutes. And that generated a whole problem. That may be an atypical traffic. It may be. But if you pay attention, that is an upstream. And usually the upstream in a commodity is not so high as a downstream. Let's see what's going on. Probably you cannot see that well, but we see the UDP traffic around 8 gigabytes. That's so weird because the cooling of the net flow as flow is 1 to 4096. So this traffic is so weird. And on the top, we found out that one server was sending 30 gigabytes traffic outside. 11211, which is the main cache door. Wrong configuration, we sorted that out and fine. But if we stop in the SNB, if we had stopped it in the ESB, that problem wouldn't have been founded. And now, luckily, I managed to find it fast and quick. We have perceived that there were some mistakes in the interfaces from JTI, L3 incomplete. At the same time, I knew that one of our partners was migrating VLANs to our network, and then I asked them, what are you doing? Well, we are migrating a Cisco VLAN that is generating VDP. That would lead to a major problem, but I didn't see anything in the S&P. Zero. This is a bouquet chart, a Python gets the syslog information and identifies how many flaps each interface had in a certain period of time. Due to monitoring, sometimes we are not able to see the flaps, and there is such a fast flop that you have 100 flaps in 10 seconds. Syslog is applied for that. And some production simulations that is in the production network, but we had simplify it. There is a traffic generator that can generate up to 100 gigabytes of traffic that will generate INT in real time. I mean, all packages will be collected, but the graphon visualization takes place every 500 seconds just to improve data visualization and not to represent a burden to the server. We have also a Juniper that will generate a JCI. It could be less than that, but we like to stress the box. And a switch dial where we are collecting every 14 seconds via SAP. That's the only thing available. Here is a test where we had two flows, a continuous and a burst, that would last just for a minute. Continuous traffic of 2 gigas. If you sum up burst with continuous traffic, that is going to exceed. And here we have a 10 gigabytes interface that is done on purpose to generate any traffic jam with a burst of 2.6 seconds. I don't see any bursts. That is collecting every seconds, every 2 seconds. That's not a very nice chart, but you can tell that there is something going on. We can see the burst coming up, then we see silence. Take a look at the point of view of the traffic generator. This is the first stream, that is the continuous, and the second one is a burst. 2.6 microseconds to go through that topology. That's so little. See what happens when there is a burst that represents a traffic jam in the interface that goes to milliseconds. It doesn't seem to be relevant, but if we are talking about academic applications of a high flow, which requires an aggressive ICL, as it is our flagship, which is the observatory that is very rubbing, that is a observatory that has the biggest telescope in Chile. Latency variation could not be present, and we would get any latency variation that is just INT, none, no other. I will stress a little bit more our traffic generator. I'll have 1 second burst generator, which is so little, 1 second. It's little, isn't it? ISP is good for many, many things, but not for burst. Let's be honest. We just see a traffic coming up, coming down. We don't see much. JTI, as I decrease that to 1 second, and they collect that every 10 seconds, we lose part of the information. You no longer see those peaks reaching 10 gigabytes, but you see a behavior. It helps, does not solve, you don't see the burst, but you can tell that there is something wrong happening in your network. INP shows clearly bursts coming up, coming down. 500 millisecond burst, same situation. In the JCI, I lose more and more information. That went down to 4.5 giga. I don't even see that there is a traffic, but as they are in the same interval of visualization of the INT, I am able to see those microbursts. And the last test, we consider the worst case scenario, that is to decrease the burst to 10 milliseconds. That became a microburst. We don't see any bursts here, and INT also loses it because I visualize that every 500 milliseconds. My burst interval is smaller, but the INT is with 500 seconds. We wanted to have that. That was beginning of our production network, but I may decrease that to real time. 20 milliseconds, 100 milliseconds. That is a way to work for the future. And now the question to be asked. How can I use so many tools with different information? Autonomic networks. As an operator, as an engineer, we will no longer looking at all of that. Although it's nice, I'm not going to look at all of that. There is no way. I have to sleep. I need to have my weekend offs. So we are going to use another concept, which is autonomic networking architecture. This RFC 7575 is self-managed. Self-configuration, self-healing, self-optimization, self-protection, where the network itself will understand its own behavior and it will recover from a problem. And attacks that we have been suffering, the idea is that the network will identify it. Our goal is to use the INT granularity, that large information use, so our network that today is an SDN controlled by a software, we want that to be self-managed automatically. I'm not going to go into details, but our idea is all these plans, control plan, data plan, they are from the SDN. And our idea is to create new plans where management plan is also in the SDN, but we want to create some documentation plan for that to show our SLAs, information expected by users. I don't want latency to be higher than X, and that is so impacting. So we are going to use all this information to feed the intelligence layer, probably throughout machine learning, deep learning. And the network, with all this monitoring and RSI information, the network and the web can be self-managed and mitigate human errors. Some final remarks. Yes, it's possible to monitor all packages with INT. It sounds weird, but that's possible, and we are doing it. INT and JTI, they increased our visibility tremendously. Remember that example I gave you about a vulnerable server? That was under production. We checked that out. We tested, and now we are using that every single day. We didn't expect that at first. And with all this set of tools,
with our users and our partners, whereas they complain, we are able to get to the root cause of the problems. And as I said, we should use machine learning to be able to create the looping and that way have our network fully autonomous. And just to wrap up, the legacy tools of CMP is great for managerial reports and to have a quick snapshot and to really be able to manage all equipment. It's a PDU, it's not cutting edge manager, but you're able to monitor all with SMP, so we'll not abandon it. There's just no way. I mean, all the tools are very useful. However, we need to evolve to be able to have a more granular monitoring. We're using telemetrics and INP. Well, that's what I had for you. Thank you very much. And if anybody has questions, I'm here to answer them. Hello. Well, first of all, I'd like to congratulate Renata. Great presentation. But I'd like to know if you have any use case in any company and also using other equipment, because on the presentation you talked about JTI, which is Juniper's, and I want to know from you if there's any other solution of any other vendor. Well, from the ones I know, I don't have use cases. I am more in the academic side, so I'm not really tuned to that, but I know Nokia does, Huawei does, Cisco does, and Telemetris does. So each with their own features, using different protocols with intervals of sending information that are different. But I still do not know which ones, which companies are actually using it. But it has been growing, and I believe that in no time it will be in the market. Another question I have is that I realized in one of the slides you're using Grafana, and I want to know from you in which way JTI exports the data to Grafana. I mean, yes, I think I understood your question. So it will be sent a protobuf to that, and you will be able to do that. And you will have this sent with the influx, and we'll have that in the database, and Grafana will check the influx. Okay, thank you very much. Next question. Good afternoon. I am Leonardo from BB Rush, and I have a question. When we talk about, as you had mentioned, NTI, in terms of storage for a day, 30 days, what is the load when it comes to storing the logs for a year or even more, depending on the demand? Well, I can say that this is the typical question I have everywhere. So, I mean, it wasn't really my focus to get into the details, but definitely, and it's something, I mean, specifically, MP it consumes a lot. So, I mean, what is the consumption of disk and how much we have? So at this point, we have disk and we've been saving everything on it. But we will get to a point that we will have to either summarize as we have with ABIX or delete, because it's just very granular information and you don't necessarily need that information. So this techniques also to really be able to save events. I mean, for each case to be able to save it. I mean, when it comes to database, you have that event, that evaluation, that loss of package. JCN? Well, very interesting. It makes me really want to know more. Well, how many teras you already have? I don't know if we've reached terabyte, but we had an article written which we applied. It hasn't been approved. We're just still waiting, but we realized that if we would monitor our network as a whole with 3 to 4 pieces of information for each interface and for each, service, for VLAN, that's our choice. We could do it differently. That's how we monitor it. We would have 23 gigabytes per day. So it is a lot. Thank you. And one last question, Douglas. Well, I apologize. One thing that, in terms of a use case that came to mind, and it's really a great passion that is utopic to me, the whole idea of a billing that's different for each type of destination. So I will bill for this SCN this one, for the other one some other one. And I realize that clearly with a real applicability to it. Has that been considered? And to complement to that, we're talking about SDN, P4, and you have to pre-code how much you'll get from granularity and information. So the event that you brought has already considered an event that will trigger the granularity in the next packages, and you have it stable and it's back to using less disk space. Let me see if I recall the first question. This point about being able, that type of thing, it is something that we have in our network, although it's academic. So that's the idea, monitor, investigate. When we think about this link and it's going through, let's go through a whole process, go from a link to another one. So this is not a flaw, it's optimization, and that's why we want to use the NT monitoring. And the other point about this variability of the granularity, yes, we are studying that, and very soon we'll have this in production. But for now that we have information and we have know-how, the whole idea is to increasingly more be able to organize these small details that we saw that are the problems is this one, in terms of making it more granular and less other times. Thank you very much, Renata, for your presentation. Thank you. Congratulations. Let's now have a coffee break and we'll be back at 20 of. Thank you.
we web consultants, and we have some other services such as NOC, mitigation, DOS, IP traffic. We have a booth in the other setting, a little bit of our agenda. What is the IX.br, IX infrastructure? How can we connect to the IX.br? How much does it cost? Some frequently asked questions and some hints. Motivation. Why are we here participating at the Infrastructure Week, addressing the minimum that someone should know about Internet exchange? That sounds a bit weird, doesn't it? I thought so, but talking to some people, we have several working groups at Telegram IX, and there are many people who do not know what IX means. Web operators do not know what IX means. Or they have questions, or they have a wrong understanding about IX. My goal here today is to allow people to get the minimum information to be able to connect and to have some knowledge about IX. What's that? That is an infrastructure which connects several providers, access providers, content, education, governments, and the same environment. An ASN, which connects to an IX, that is a large switch where everyone would have a connected cable. São Paulo has a network of high complexity. It's quite complex to have ARP, suppression, VPN. There are two large Cisco boxes with two portals of 40 gigabytes connected, and IX randomly is a large suite where everyone who is connected to that may exchange traffic. Internet exchange, that is the acronym. In Brazil, it's PTT. Before, that was a former acronym, a point of exchange. And then we have some other denominations for IX in other countries. IXBR is Internet Exchange, and that is the name. It was named after the CGI project. CGI, BR, with its own resources, due to the name domains, decided to run a project which would improve Brazilian infrastructure, Brazilian internet infrastructure, and it became a great success ever since, and it was designed to promote network connections. IX.br is available throughout the country metropolitan networks where there is a high internet exchange. The Brazilian IX is the greatest one in number of participants and volume of traffic. It's really a shame for those of you who say bad things about IX.br, as it is one of the most serious and liable IX in the globe. We have the greatest IX in number of participants and traffic. And that is supported by the domain register, although you pay for a port. And the amount paid monthly per port is a very insignificant amount. So they don't even say to pay. They say something like infrastructure sharing or cost sharing. We don't even consider that to be a payment. IX is spread around 35 Brazilian cities. It's cheaper to take that than to pay for an IX traffic. IX infrastructure in São Paulo, we have the interconnection point, PIX. Interconnection point. What is that interconnection? It is a data center which hosts equipments which are part of the IX infrastructure. We may take any PICs, which they are a predefined data center. They were not created just to be a PICs. There might be one or another at smaller places, but in São Paulo, we have giant companies such as Equinix, Level 3. They are pre-established data centers. And they allow infrastructure, fibers, for IXBR to host its equipment and to promote connections among participants. How about CIX, 6, Intermediate Interconnection Point? I am a 6, and then I transfer that to someone who will connect to my suite, and I am connected directly to a PIX door. 6 itself, it's a larger door that is shared with some other participants. And the idea behind it is to mitigate costs. AS 65022, that is directly linked to IX equipment. This is the ASN suite, which is directly connected to this door. Whereas the AS that is connected to a suite to the 6 owner, and the 6 owner is connected to the suite. I may have 10, 20, 100 IX participants being connected to one single door. We have 100 giga ports. In a 100 giga port, you may have like 10, 15 IX participants. You may share costs, and then you will understand that 6 connection becomes cheaper without losing any quality. No, it does not lose a connection to the house servers. This is the São Paulo City IX infrastructure. All PICs somehow are interconnected. Those who are in the PICs OData, they can talk to the PICs Syrian, PICs OData and PICs Syrian. All data centers are interconnected within the IX infrastructure. You may ask for a collocation, ask connection, and connect to IX. That can be done easily. One participant talks to another one just for being part of this mesh. May define a bilateral VLAN, does not matter the PICs where you are. Any PICs in IX São Paulo, you will be there, regardless of the PICs layer. This is a different infrastructure from Fortaleza city. We have a smaller number of PICs, but you are connected to any of those. It's just a matter of connecting to that. This is a very small IX in the city of Maringá, where there are just two pixels, UM and VSX. Some structures, they have one single pix. It's called the central pix. You connect and you may exchange traffic within that regional traffic point. How to connect to IXBR? First, you have to be an ASN and you have to provide your physical connection until the desirable IX. If you come from the capital and you have some fibers going through some of those data centers, you just pass your fiber through, you connect yourself to IX. If you don't have it, you just allow some transfer. Register yourself at mail.ix.br and ask for connection. Right after that, IX will supply some data throughout two different VLANs, one for IPv4 and another one for IPv6. Participants will close some requested BGP sessions by the IX, and after that has been approved by the quarantine, you are ready to exchange traffic with everyone who is present in that IX. And how much does that cost? This is a recurrent question. What's the price? Costs are covered by .br registered domain. But those registrations that go over 1 tera, there is a monthly payment that is charged by port or connection 6. Different types of ports, 1, 10, and 100 gigas. And Julio told us that we may have 400 giga ports. To participants, there is not a due date for that yet, but soon. Stay tuned. And we have the 6 connection. If your 6 is 10 giga, this is the max you are going to pay, 115 BRLs. And for a 10 giga door, 690 BRLs. Even if the 6 operator charges any additional fee, yet it's quite cheap and you'll be able to connect. Well, I pay 20,000 BRLs for PTT and for IX, and I just have 10 gigabytes. No, that's not the case. People that are badly informed, they say so, but you don't pay 20,000 BRLs of IX monthly. No, you pay for costs. You pay, you have to cover those costs, fixed costs. Anything that goes beyond this, you are paying for your own transportation, co-location, cross-connect, or anything else that will compromise your connection with IX. If you have 400 gigaports, you are not going to pay 20,000 BRLs to the IX. Our IX is quite cheap if you compare to what providers are used to pay abroad. Most IXs, they are paid and they charge a much higher price for an IX connection. Frequently asked questions. ATM. ATM is an agreement for multilateral changes. That's when you close the BGP session with route servers. You announce your routes to route servers, and anyone who's got the closed BGP with the route servers, they'll get to the routes, and then you may exchange traffic. This is the IP that you are able to close a BGP. No other participants are obliged to exchange traffic with a participant. There are some domestic carriers Vivo, Embratel, Oi, they are there, but they do not exchange traffic in the ATM. That is their own choice. They just don't want to do that. They are autonomous system number, and they just exchange traffic with those they feel like. There are international companies in the IX that also do not exchange traffic. They make use of the IX infrastructure for other means. VLAN bilateral. You get another participant IP and you say, well, let's close here a BGP session between ourselves using the ATM IPs. There are companies which are in the IX and they do not exchange ATM traffic. Case to illustrate is the Apple to be in the IX BR São Paulo, but they do not exchange ATM traffic. If you want to, you have to ask for a bilateral BGP session where they are going to announce their prefixes and you do the same, and just then you'll be able to exchange traffic. Bilateral VLAN, what's that? That's a bit different. This is a layer 2 circuit which will link two IX participants in a single circuit that's widely used for IP traffic to mitigate any DDoS attacks or to allow some sort of peering with someone who does not feel safe enough to do that through ATM. IX or traffic? Well, IX, because that is cheaper. No, that's not quite the case. You are not right if you think so. IX is a confined means where there are several CDNs, where there are several content providers such as CDNs and others. But that is a confined means. It works in silos. Regardless the size of your traffic, you won't be able to add connectivity to your clients if you just deploy IX, except if there is a IP traffic next to the bilateral VLAN. IX does not replace IP traffic. Regional IXs, in addition to the main hubs such as São Paulo, Rio de Janeiro, and Fortaleza, the IX.br operates some other regional IXs, such as the city of Maringá, Rio Preto, and Cuiabá. And those of you who live close to a city which has an IX, connect yourself to that, because that's a paradigm. I do not connect myself to that IX because there is no CDNs, no content or whatsoever. The CDNs are not there because there are no participants. If you are a small provider or vendor and you live in a town where there is IX, connect yourself. And probably a CDN will be there available. Global television broadcaster was addressing that the other day. And if you have an IX in your city, you are going to take the best use of that. Is IX if that is so important, why don't we interconnect them?
And why do we have São Paulo interconnected with Rio? Why do you have the small from Cuiabá with São Paulo? The BIC's role of IX is to reduce latency and cost and mainly keep local regional traffic. It makes absolutely no sense whatsoever to interconnect IX and bring these two routes together. The whole idea is to not have some confined or anything like that. In terms of having the CSN, this is not the purpose of the project, and definitely we're not going to have that come through. Many people, and I've had many discussions where they say, oh, but you need to interconnect to IX, and no, that's not the purpose. If you want to have redundancy, connect with both. São Paulo, Rio, Fortaleza, or have something in your traffic. That's not the purpose. So does it determine all the national traffic? I mean, thinking at it, no, nope. As I said before, UTIM, Vivo and Bratel Tiro, they don't have traffic in IX, so it's not there. So we have other companies as Electro that does have, and it's not an electric one like Hurricane Electric. So there are some routes and some content. However, I mean, it was not made to have all this capillarity, nationally speaking. And another question is in terms of how much of traffic you have, because each SCN, I mean, so thinking about what it would be. So a provider, thinking about those that have residential in the countryside of São Paulo and link to it without caching this type of thing, and you don't have GSN. I mean, so it has 60% of your traffic for IXBR. If you have 10 gigabytes, usually in this case, 7 gigabytes will flow to IXBR. OpenCDN, which was widely spoken, but just a bit more about it. It's an initiative that has been led by NICBR to foster traffic in the smaller IXs. The dilemma I said about the chicken and the egg, I mean, when we think about it, so thinking about what they said, so you put together the people from CDN, where we have Global, Google, Microsoft, Global, Google, Facebook, Netflix, Cloudflare, Akamai, and to be able to take this to some other places and to have this in the data sentence. And it's important to foster this. It's important to say, so there is a cost to it, so each will pay an amount, so which is actually the split of the cost to keep the local infrastructure, because there is cost because of the CDNs. And Cross Connect, which is called also Golden Jump, the name given to the interconnection of racks. So when you get to a data center, you have your switch on and you have your fiber that you need a cross connect from the rack where you're at. So you hire this, which is done that to the data center in terms of cross connect. So this should not be charged by this, so it connects this with the IX, and you can have a hack of that data center all the way to traffic. And PNI is the acronym for Private Network Interconnect. So it's a mutual exchange of traffic. Many major content providers. So it's a cross connect, which comes from the rack of the provider all the way to the CDN and the rack of the CDN. It has the sharing of the traffic. And the name of this is called PNI. Peering is the act of establishing a peer BGP to exchange traffic. It can be by PNI, route server, bilateral session, so on and so forth. Colocation is a data center service where you rent a space to get your racks in. And lastly, peering DB, where you allocate a space on data center to get your equipment. That's what I meant. It's charged monthly, and peering DB is in a website where all SNs can register to make available their information by SN. We have data center, ASet, IXS, so on and so forth. And then here, talking about the pure IP traffic, where we have IX that was condemned some years ago because of the problem, so on and so forth. And many sellers say, oh, I have a pure IP traffic, which means that goes through any peering and no cache. And that's a mistake because internet is only possible because you have all of that which we're talking about. So it's only possible because there's IX, there's cache, there's CDN, there are the PNI. So all of this brings the best experience to users. And users will thank you for that. As much as you buy traffic from wherever you are, it will go through a peering or through a PNI. So pure IP traffic is fake. An interlinked scenario to IX, so IXBR, SPs here, there is a hired transportation and it's connected. So it pays for a PIX port where it can already change the traffic, order bilateral VLANs, and it's necessary there to hire a cross connect between the equipment of transport and the rack of IXBR where it's hosted. Another one here, which is basically the same thing as the previous one. The only difference is that now you have a 6, so it's cheaper. You can bring ISP all the way to the 6 switch, or you have the transportation already as a 6 for XBR, and then here it's connected, so being much cheaper for you. The possibilities here are even greater because 6 can really have a burstable traffic through a VLAN going through your transportation, because if 6 drops, you have another option. You can allocate the switch ports to you so you can have a PNI or have a bilateral VLAN if you'd like to. And here is the most desirable scenario, the one I like the most and which I really seek. Would you have a transportation through ISP, you have a switch, whatever it is, and then you have a cross with IXBR, Google, Facebook, Amazon, and PNI, and then you buy an IP traffic. And because you have any problem here with IX, you'll have the flow of traffic through here and to Amazon, and also the percentile that you have in your IP traffic. So this is the thorough and most complex, but is much more resilient for everyone that wants to get connected. So, some hints here for IX connection. Always apply local preference that is greater than traffic on the BGP sessions with its route servers. Always. If everybody who is on IXBR would apply local preference on the BGP sessions with route servers greater than traffic, nobody would need to really get the out servers of /24. We would not have 200,000 routes by now on IX São Paulo. But avoiding more announcements on IX, and only if it's necessary. Wait a second. But if everybody would use this, this would never be necessary. Adjust your time in your router. So thinking about this, I mean, you have nearly 3,000 participants, and you have this whole blah, blah, blah about RP, I mean, which is something, I mean, where you have too many routers. I mean, and something like that, and trust the out servers. Request bilateral sessions only when they make sense to you or for appearing. And that's all I had. Very simple. Thank you. It was just to make clear to those who don't know, to be aware of it. Any question to Junior? Jenny, go ahead. Good afternoon. Karaza here. Congratulations for your presentation. Much information there. 2 points. First, I would like to suggest maybe to create an article on BPF about this content. It would help a lot of people, and to complement also with the presentation that will be recorded on Nick Vieira. Is that okay? Are you committed to it? You bet. Send me an invite. How about that? The other point also, it's related to the regional IX. One thing I've noticed is that sometimes in some regions you have a average size one, and they take part on the smaller IX, and it announces what it brings for this regional one. But since it's traffic of that client, it will announce the one that adds the most, and that's why the smaller one that gives a transportation for the IX in São Paulo, it's not only with the AX directly to that one, but many times announcing more specifically. So many times you don't have a lot of traffic there through that to take that to the client based on what you have. One way that I see that perhaps we could do that and would make sense, because in theory the cost of transportation for this regional one is cheaper than what you would know that the provider could have for São Paulo. If you could make sure you would have more six for this type of regional ones through this traffic provider, and that way client could announce to the road service there, and I think it will be a win-win situation. So I'd like to know about you, what do you think of it, and if there's any other way to think about to share that even more, unless in São Paulo, for these scenarios. The best way to go is to have traffic with informative ones. So although other ones that come to it and have the community 300 or so, it will inform that this community is from the regional IX. So you simply do the match in the community and you will allocate the local preference. If everybody does that, you solve the problem. To have more six is important, but we come from regions, as you said yourself, where the person who sells traffic will be the same that will sell six. And for the one that sells six, it's not important because he charges more for traffic than transportation. So definitely to create, this is definitely important. But to so this is something that's very important, and somehow to get connected without having to go through anybody. And another point is that if nobody wants to do it, somebody else will. So if somebody does it and you have more for this, I mean, the person who will have this will also have to do the transportation, because the market will regulate that. Tiago? Hi. Thank you very much for the presentation. It's good to just talk about everything. I mean, for us it's easy to understand because we saw it all happening, how internet exchange came into it. But those who are coming on board now to understand how traffic and IX are related. So I want to know from your opinion about the following scenario. Many providers, specifically because of the herd effect, are always thinking about IX in São Paulo. So I will talk about a provider that during the construction work says, this home is very interesting, so let's swap. I will give a service of yours in exchange for your fiber. So what he got in the swap was a big traffic from his state to IX São Paulo. When he told me, and he was very proud of it, I said, what about the IP traffic? He said, why? What IP? So he thought there would be no cost to connect to the internet he had with his big carrier, that for them traffic or transportation the same, since in his mind all provider needs to be an IX in São Paulo. Every Brazilian provider needs to be. When he saw this big opportunity, this moment of having paid fiber with his transportation for IX São Paulo, but he still will need to pay by hiring IP traffic. So with this confusion that many providers and managers have, I want to understand your opinion about those who are away from the southeast of São Paulo or southeast region. I mean, those that have access only the residential one. What's your opinion, please? In my opinion, my technical opinion, depends where they are. I think so. A person from Bahia, for instance, can get connected to São Paulo. But who should they? Depends. What he can have is a connection to Sao Paulo and maybe one to, I don't know, Fortaleza. Should he? When it comes down to it, no, he should not. But who will he buy traffic from? From a carrier there. And where would that be? Where will he take this to? São Paulo. So it is the herd effect. And in a straight line, if we look at this scenario, I would say no, it should not buy IP traffic from two places, and that's it. But he'll always say, thinking about the situation today, wait a second. And he's here from my region, so I'm paying R$2 for him, and the transportation is 150. So a provider as a whole, I believe, the transportation, I think it's more expensive than R$2. But he thinks that he has an advantage there. Provider usually have this feeling where they feel that there's an advantage there. That's why they do that. But no, on a straight line, if you look straight out, say no. Buy IP traffic, and that's done deal. Julio? Well, first of all, congratulations for your presentation. We don't have much time. I'd have to go back to your presentation and list a set of improvements, but just to bring two things here. One, it would be interesting, to have you present a bit what I see is the access to content, to the total internet content as something that is hierarchized. You have the hierarchy, you have the small, medium-sized provider. At the end of the day, it will come from any data center here in Brazil. If it's not in Brazil, we're going to have international one. But then it depends. He has a PNI or he doesn't have a PNI. So we see from my São Paulo where there is a much lack of activity. The idea is to have a hierarchy idea of everything. The content, won't go straight to a part to the end user, but one will go to have this cache from the provider. There's a whole ecosystem. It would really be great to have a presentation there, so maybe to have an idea of the provider. Where does this content comes from? Okay, it's this and that I'm sharing. Okay, I understand. And I have another question. Does IX São Paulo with 20 teras, 19, what about if we had this hierarchy? Would that be the case? It's already there. And if this provider, who is 18,000 kilometers from there, from Manaus, if it's not connected here, the person can have a traffic IP from another provider there that will have a PNI with content or will be connected to IX São Paulo announcing this. It depends. I just mentioned Tim in Bratel there. It's not the case. So it's something that I say also. So we wouldn't really be big, and you wouldn't be as good as what you do if we didn't have that, because then you wouldn't have any traffic, and there will be on their own PNIs. But I understand what you're saying. I know where you're coming from. Well, XBR is a category of companies, right? The major ones don't really share traffic. I don't think there's a package related to phones that go through IXBR. I think CDBC does. Okay, I might be mistaken. Anyway. And two more questions. So talking about CTB, RPKI, manners, and all these obligations that we would like all participants to take care of, have the information that is updated in the .br. So this is part of our own ecosystem, and that could also be included in your presentation. Okay.
That is a suggestion for next year. How about that? Well, I thought that you would be nasty to me and ask those really complex questions. Congratulations for your presentations and regional providers. Congrats. I have three questions. First, that in the figure 70%, I work with several providers in the country. And these are the figures. There are some that reach something close to 90%, but the reality in other Latin American countries, that's so much different. I know that some people, they have complaints about IX, but once you go to other country, the traffic composition is the opposite, 80% for the traffic operator and 20 to IX. Second, I've heard several people saying that the Open CDM program, they have to establish a traffic with a specific community to upload that. And I have perceived that. And there are operators, carriers that are not even able to do that. They get the Open CDM traffic, and if the communities are not getting Netflix or Google, so that is just a piece of suggestion. In the next presentation, maybe you could have a template as how we could set that up. Despite there are so many consultant companies in the country, there are some that work with small carriers, and they are kind of lost. My name is Carlos Bascoyan from the Federal Prosecutor from Paraná. I am part of a public company, and I think that we should include those public companies that don't pay anything to connect to the IX. And that's also important. So the public companies, they had to participate at the process, and in São Paulo, as we do in the fourth region, to foster the content and to take that content closer to small providers and also to consume content from São Paulo. Sorry, public companies don't pay for the IX portal? No. No, we don't. Okay, I'm gonna save that information for the next opportunity. Public entities, academy, public academy, army, judiciary power, governmental agencies, they don't pay. Well, it's understandable. That is an important content, and sometimes the public company, they find so hard to participate at a project like that because they don't have this type of information. This is our case, so we try to promote that, to bring and more public companies to the project. I think public companies, they should participate at the IX and be closer to what is taking place. Another topic for next year's presentations. I have 8 suggestions for next year. As we have people from the public sector listening to us, don't put at the editor that the internet link should have connection to the U.S. International backbone with the U.S. I got once that they made mandatory that you would get connected to 2 international traffic points. Thank you, Junior. A big round of applause to you. communities. Some time ago, we didn't have issues like that. Black hole has been released a while ago. What is the priority in your opinion? What haven't we got and we should have? The big bid. I used to work for IX, but I left. What is missing? It's what Julio has promised. The IX portal, it's very, very weak. But that has been promised before. That's quite bad within the IX organization. IX as a whole, I cannot say much about that. And talking about portal, what I realize anytime that there is a call or something like that is that is triple-fold the answers. My name is Andrea Fransage. I didn't introduce myself in the beginning. Thanks. Thanks a lot. Next, action of the day, Douglas Fisher. Made for it solutions in IT. He'll talk about templates and configurations, IX, and main router sellers or vendors. I am Douglas Fisher. I work for Main for It. I am automation and control engineer. I swear a lot. I apologize for that. These are my disclaimers. If I swear, I'm just swearing to someone who deserves it. It's not you. What are we going to say today? That could be the opposite order to the route servers. This is a quite polemic issue. And some cautious. I did a presentation at LACNOG. I talked about behavioral criteria at IX. If they have to adjust their behavioral agreement, let's try to establish to help them to correct it. Increase the local preference, and to be more specific, that is always a low horse. Import, export to route servers. Best practices, filter guide, manners. We have much more to come. How about methodologies for route filtering? Not just route filtering, but anyone. Blacklist, whitelist. You deny what you don't want, you allow all the rest. And complementary, you may hire some exceptions before you deny anything and treat exceptions before you allow something. This is the basic concept for filtering ACL. The rules are more or less the same. Communities. talking about BGP and IAX. That's a reference to a friend, Thomas Lynch, PDF of the presentation and the video talking about communities. Important information about communities. OXP or traffic vendor, they must have traffic engineering. Are there XP with no communities? Yes, there are. Are there traffic the people that don't have communities? Yes. If you're going to hire any one of those, just run away. Don't hire them, okay? If you are not signalizing your communities with your routers, you are doing things wrong. And if you exceed with communities as anything in life, you are gonna lead to problems. I have a friend, a professor, that is conducting work regarding the excessive use of communities that increases the use of memory at routers. That is like a sauce. If you put too much sauce, that is not nice. If you put less sauce, you cannot eat well your meals. Still talking about communities. A suggestion. This is not in the IX. BGP routes coming from all places, originated routes, those that you put at the BHAS /24 or /22. Eventually, during aggregation, where you originate your route, or in smaller networks, the aggregation coincides. At the time that you are originating, it's not just place that at the networks and originate it. Go horse, place a filter to apply communities, because if they no longer exist, they are not going to propagate without their communities, and that will make sense because the whole filtering should be based on communities. We have CGNet routes because you have to do whatever you can and send IPv4 to that direction. Upstream and downstream sessions. I learned about that route in my level 3 traffic, or maybe I've learned about this route in another transit. You are going to keep that with specific communities. And if you can do that with elegance. If you don't know that about that route communities, what are you going to do? Prefix list? PNI, Samara free. You have a PNI with Facebook. You want to know within those routes, you want to know what are those that came from PNI. If you don't know, you're doing something wrong. Same thing with route servers. We are in an IXBR event, but that's not the whole IX. There are some other IX in the globe, and you have to mark them properly. Just a piece of observation. I'm trying to be brief. I don't know if I'm speaking too fast, he says. This fun example that should be better designed. That's not a nice example for communities, Mark. Let's say that you have a prefix, the first chunk of the community 65100, and if that is a own route, if that is a route that has been learned by another client, if that is a peering partner, if that is a bilateral over IX, I Delta PNI network, bilateral session over IX, it's still a multilateral agreement exchange. Regardless if you are going to exchange that for route server or for bilateral session, that is still a multilateral agreement. What matters is what goes through and not the route. Here we are talking about marking the sessions to be able to filter that properly later. I highlighted those routers that are served by IX, and here could be the IX São Paulo router, or it could be the route servers for the FILIX, or pay a honor to Gustavo, who created himself an IX. It could be an IX with this community or all the upstreams. Another example is that you go in your FIB, in your environment, where you create a community for distributors, black hole. So you have to keep that, and that will be redistributed. What are communities? They are labels that you have to place at the routes, and then you have to take a look at those labels. What is the filtering methodology? Under which conditions? We have different types of peers, IBGP, neighbors, IGP. This is the route that is originating in your router. BGP, your router neighbors, your BHAS with aggregation router, traffic clients, peering, and route servers, IX. You have the AS cone defined for your traffic client. What is that? You are able to know exactly what will be the ASs that will be behind the BGP session. If you have 5 or 6 ASs, yes. It's back. These are some examples that where they will construct those filters for route service X, IX. Which routes am I going to announce to my route server? I will announce, and those routes that I learn after my traffic, no, I will not do that. And how do I know which are the proper routers? Let's take a look here in this funny table that we have a 65100, 65101. So they should not be announced.
But the 6500, 65108 are my own routes, which I have in my iOS. If we talk about IPv6.4, it's per community. And the ones that I learned from my downstream, I'll have that in the route server that can replicate this to the other ones. PNI routes, no. If you read the documentation of all the PNI agreements, it will give you the orientation of not redistribute the PNI within the servers of XP. You have a lot of issues arising from it. And this is just a basic. And then you can think, let's just enhance. What about if you need to redistribute black hole to server? How does it say? I'll test if there is the own route that was originated by myself within my scope, and I mark within my community 65.535.266, and I'll apply this, which is community standard with black hole, which is in document with a black hole, and I'll have an accept in the filter of exportation that I'll export to the road servers of XBR, Exequinit, FLX. So do I have here prefix list? No, you should not use it. Prefix list is where you have a definite one. So otherwise you'll have a huge problem, and then that's when you start screwing it up. So don't go there. So okay. Importation filters for application in the route servers of IXP. First validate the RPKI. So route servers of São Paulo RBR as a whole are very good when it comes to that. Very good. We had problems in the past. I recall having had problems. Oh, people would joke about it. So thinking about it. So, this is not what we're having. But, there is the possibility of having an issue. And are we going to have this? The whole system, you can have a problem. And there's a principle that I have mentioned before. You cannot say that you are trusting the route server worker to accept all the routes you have. It's your duty to learn about the routes. So you need to validate, you need to reject prefix with a short mask with the P4 if it's less, the mask is less than /8. Bogons, XP lands. This is something that we need to really pull the ears of some companies. They redistribute the LAN on DSV. You got to pull their ear, don't you? And even if they deliver that, you should not accept it, right? And for the other one, you won't accept anything. So if you take a look into this, you'll see that you have tier 1 and they're filtered. Because tier 1, depending on the concept of tier 1, but you do not have tier 1 that can bring you this, that will allow you to have this. And what about if you have this router? If you have some issue there, are you going to accept that? Are you going to impact your clients? It's your obligation to filter it. So, something that has a long specific IXP. Those that are less radical have this as 100. For the filter guide, it's 100 AS on ASPF. I am more aggressive there. If you have 50 to get to a route, it's wrong. That can't be working. You got to clean it. It's not a healthy route to have more than 30. So I think 50 is too much. Those that have many prepends, the same cable that's doing this work in South Pedro, who is working on this about excessive use of community, did some great work on this use and the lack of efficiency. So actually, more than 2 prepends, I mean, it won't work. More than 3, forget it. I mean, who's doing it doesn't know what they're doing, right? So this is really great. Take a look at it. I am a guy who is participating on XBR São Paulo Rio, and I sell to Corazza or Ayub. And Ayub also is on IX. I mean, what do you have? Well, if I accept the routes, I can learn Ayub and ASN, and instead of delivering the traffic directly to Ayub, I will be going over the IX matrix if you want to have a secured network. So you will filter these routes, I mean, so you don't accept them. So how are you going to do that? I mean, I prefer this sequence. So you can do this just by rejects AS path. So you will check this and you will reject these routes. But this usually is very CPU intensive. So every reject is CPU intensive. So you discard some of the routes by using at the rejects community that IXP will mark. And I believe all of them would do that. With IXBR, you have the ASN. 32, 33 bits, right? And then you can save up a bit on the CPU of your equipment, and then you take rejects in. And what else? Let's see. Here I'm talking a bit about the imports. This is what we should reject and to accept. This is a divergency that we have that is really something that we have with nearly all our colleagues. I mean, apply local preference as traffic and accept. Why as traffic? Because if AS of Ayub went through Algar in the Algar route and came to me, there's an extra AS, then when it was sent to me, when Ayub sent to me, local preference is one of the strongest argument when it comes to choosing argument for GDP. It's just very strong. Don't try it too hard. I mean, what I'm saying, just leave SPF in its size, its path. Don't go strong on local preference. This is something that is a divergence, and this is something that can really get an issue. And if I want to get this better, remember the slides here talking about the communities. I mean, talk to them. If you have, and I'll bring here examples of XBR we have on the out servers. If peer has lost more than 10%, you don't want to talk them through that. You want to reject them. You want to ignore them. So what are you going to do? You're going to see if the route comes from a community with 26162, 64, 661, you're going to do a reject on it. And just leave the traffic to solve how to get there. You don't want to get through there. And if there was a community of peer with latency less than 10 milliseconds, and here I'm talking about enhancing your mechanism of filter. This is an extremely basic example. And if the peer is less than 10 millisecond and you have this here and it's written with 26162, 64, 661, and then you will get your local preference of traffic. And here I have 20. It depends on the scale you use internally. And then you'll accept your route. Okay? And if the community of peer with latency shows 26162, 64, 667, that means right on the table that IX offers you says that it's more than 250 milliseconds of latency. There's something wrong going on here. So will it always be that way? No, we need to adjust. So the mechanism of route server is great, it's magic, so you're going to redo it. And I'm not sure how often, but it's every 4 times a day, I would say. And then you will apply local preference of traffic, and then you're going to remove 20. Why? Because in this case, through IX, you're taking more than 250 milliseconds to get there. I mean, you can cross the world, period. I mean, okay. If it's satellite of high orbit, no, but if we think about submarine fibers, you'll definitely cross the world. If peer is taking more than 250 milliseconds through that, and you don't want to talk that through that. You go through the traffic. When you have traffic, is outsourcing responsibility. You're getting it. And I'm saying, look, I can't reach everyone. I'm just hiring you to take me around, right? So in this moment, I don't want to use a round through XP, so you will remove. So 120 here, I'll give an accept on the route. Why would I do that and to have it worsen? Because maybe even with the traffic, this is still bad. So you still have a way to reach it. And at the end, after all these tests, with the remaining routes that you did not have any problem here, you can apply local preference and accept. Here I just shortened because I know I wouldn't have time, big time, so protect your box. What is the main way to get it done? The right way to do it. To use VRF. VRF of management. Check on the documentation of Cisco, of Howie, Juniper, and Arista. All of them give that orientation. You should not have the management of your box where internet goes through. If you're doing it that way, that's wrong. But we know many people do that way. So still, if you decided not to, let's do it through the basic form. At least have their preference list so you can check the origin and filter all the protocols. And here I have a few: SMP, Telnet, SH, HTTP, Winbox, API, and TP. And see, this is something great when it comes where Julio to really publish the reason why you have those that are not approved in quarantine. Definitely this will be at the top. I mean, some because of number of matches, I'm sure SandP. And here we have a script that, as I'm not really into it, I really got to it here. It's really neat. It's micro ticket, and it's really interesting. You have it running, and you can apply on the server of microtik. I mean, that's just if you want to share. So prepare your box to talk to as many people on the same place where we're talking about. I mean, you can't make a lot of noise with max entry. So here, max entry of the protocols. You'll have a maximum number. I should have said this. I apologize. This is for São Paulo, for Cascavel, where I come from, where there's less than 256. We don't need to do this. But for São Paulo, which will reach 3,000 IPs, because many participants with multiple IPs, you need to put this up. So you are going to increase the number of neighbors here. And this one here, you need to push this up. And this one, I mean, this is definitely the winner of screwing it up. So MikroTik was main purpose was to be a hotspot, and for hotspot, I mean this type of thing. So I think it was interesting. I mean, to have the ARP, and you need to download for 30 seconds. Okay, it's here. It's here. For a hotspot, that's smart. But for IX, that's definitely not good. I mean, what should you do? If it's for routing, you're going to do that in the global or apply this to the interface. And this is an example of an interface, and you'll apply a timeout on 24 hours. Why 4 hours? It's a reasonable time, I would say. So this is reasonable. So Juniper, let's talk about CPU protection. what do we have here? You probably heard about that in the past, about box with a CPU topping, because not that they need to respond to ARP, because I can't know if the package is for me or not before I get it. So you need to upload, leave Softbridge, go to Northbridge, process through CPU. Okay, this package not for me. I just use CPU for no reason. So you have a policer that will be processed, and you're like, everything that's ARP with a limit of 2 megabytes. Once you get over this, it won't be uploaded to CPU. That's a way to protect your box so you don't have your session down when you have an overflow of ARP. So why should you? With all this processing of CPU, CPU can't process it. And ARP timeout on Juniper. I don't know if this has changed, but I think it hasn't. Set system ARP aging timer 240. That means 240 minutes. And prepare to have many friends, not make a big buzz about Howie and here, which is similar to policy of Juniper. So you're going to have a CPU defend. I have number 3. And then on slot 3, I apply the defend policy 3. And what is in there? If it's R, copyright of 4 megabytes. And maybe it's too much even. Or another important point is I've saw some silly things of having 10 megabytes. If you get an attack of 10 megabytes of CPU for ARP, there's no box that's going to hold it. It's going to crash on you. So the purpose here is to not have ARP upload to CPU. If you have 10 megabytes, I mean, it's not going to be able to run it, and it's definitely not going to run. And here on neighbor solicitation with 2048. Here, this neighbor solicitation is less of an issue because it can do a workaround and puts a pat with MAC address there and can be filtered right on IPv6 or filtered on the main one. So not build up dust. And just trimmed here about, I think I had 10 slides on this. But basically what I'm saying here, what is actually dust buildup? I mean, if you have Discover Protocol and all of these other protocols of discovery, you're doing something that you're screwing it up. IGPs, that has through multicast, it becomes broadcast. I mean, on an interface of IGP, please, no way. And I've seen, and I have some points that have been recorded where I've seen people requesting IP going through the PADI and VLAN of Ex São Paulo. What a good thing. And we have then, I mean, it's just as long as requesting to have a server in this interface. The same way that we have with DHCP and also the ARP, the free ARP. And these are just to make a noise. I mean, which can screw up your routing. I mean, something that's important is to have this within the routing and to be able to make your router go through another IP so that you can deliver accordingly, which is much used in proxy ARP, proxy ND, and IPv6RA. You are announcing that you are the one that you're in the gateway. You're the one default gateway. So send it to me. So if anyone gets these packages here, you will see that you're getting in the way of the person's table routing. So you are definitely screwing up.
If there is anything wrong, like if you deploy IPv4 in the v6 VLAN or the way around, we cannot have neither v6 in the v4 VLAN, neither the opposite way. I don't know why, but I feel so anxious when they place 6892 in the same network address. What's wrong with them? Well, that's it. We have just 2 minutes for your possible questions. I just would like to emphasize, which is local preference. Don't place local preference in the go horse mode. Take a look at the communities. I was very brief in my analysis. You may look at the communities and the peer will apply it. Your suggestions of the microtic for São Paulo, what is the default? Microtic? No. And the Howin, the default is 1 mega. You are talking about the number of neighbors. 2048 for IPv6 and around 1,000 to IPv4. Yes, Rio is /22, 21. I wish I had extensive templates, but I, exceeded 50 seconds my time, so I had to shorten and shrink my presentation. First question, please. Congratulations, Douglas. I am Thales from USP. What is your opinion for the mid criteria in comparison to the use of local pref? ASN is the best way to define where that traffic is going to, and sometimes it's a bit aggressive to have the local pref similar to the traffic and not make use of the mid. That is not a well-applied criteria that could influence in the use of a multi-X, which is becoming popular in the market. Now my second question. What is the best practice to avoid the full route? Would you interpret that the best use is going to be ACL, automated, or maybe the use of VRF? This link takes us to an explanation. What is the criteria name? MAUT, is it a discriminator that has been written by the fathers of ASN? And if you have the founders of BGP, they say that if you have 2 neighbors, you may use the discriminator to understand if you should go for track A or B. If 2 ASN's clients, they meet at IX São Paulo and IX Rio de Janeiro, do they have a neighbor between them? Yes or no? This is a multi-exit. And following the route servers, they do a transparent MED. You apply it, they will filter it, and they will accept it. I agree. Perfect. And in these other presentations. And this is a very ludic example about the second question, filters. ACL, if you have a ultra super automation, fine. If not, that may be dangerous. There is a presentation made by Rubens Phil. Actually, Anna is the speaker. Roger Pramer comes in first place from the female setting, and then Anna. Anna, she's fantastic. She's got a concept called BGP-QoS, and they interact with the data plan, with the package referral. If that is not a route, and if that is not similar to a thought router, QoS X, and then you drop off the route. As my time was short, I didn't have time to cover everything. Thank you. Congratulations for your presentation. I hope that you can keep repeating your BGP best practice presentation next time. I have a pull request. Many people, they make a mess between CDN and cache. CDN is a set of companies. They might have a server in their infrastructure, which is cache. Cache is the name of the server and not CDN. And many network operators, they use the same terminology for PNI and cache. You may have a problem with your local cache and not a problem with the PNL. And if you are dealing with the same community, you are going to turn on and turn off. So please include that cache requires a community, and PNLs, they have to PNI, they have to make a separation between whatever is kept locally and whatever is remotely. Yes, there is the cache bring home and cache interdip. The home is the one where you just deploy over the hack, and that is a eBGP. And yes, I agree. Let's avoid the mistakes. I'll try to correct that. And at my company, they're bullying me. They say CDN. No, it's cache. So it's like, they make fun of me via WhatsApp. So it's cache, please, not CDN. I am André Diaz from X and Words. Thanks, Fisher, Exa Networks. Thanks for being such a great evangelist. And let's make clear here that you mentioned that scenario where you have to filter prefixes of IX of the non-stream sale to avoid some incorrection. But let me make a comment here. I got several operations that, in addition to drop the prefix by IX, they would also drop by the operation. So please don't do that. Congratulations to Nick.br for this brilliant event. Anything else? No? No, that's it for now. Thank you. Now I'd like to call Milton for final remarks. And in the meanwhile, we are going to submit an evaluation form to your email. So please answer our evaluation. This is our 16th edition of IX Forum, but we always have more to learn and to improve. Well, finally, we have reached the end of the event. Our 12th infrastructure internet week. It started back then with security, safety, internet management, and then the IX Forum 16 in the past 3 days. I'd like to thank you all. We had over 600 participants on site, over 1,500 people who registered to participate on site or online. I also would like to thank those participants who joined us remotely. I do hope that you enjoyed the content, our agenda, and I couldn't thank enough the communication, Nick.br team, the IX team, our dear speakers. I bet they worked really hard to turn this event into a success. This is an event that we bring together to develop networking. The first IX Forum, we just had the beer time, the happy hour time. It's very important to have this network to leverage new friendships and to share knowledge. I hope that you enjoyed as much as possible. We did our best to leverage your experience exchange, to make new friends. It was wonderful to see you all again after 3 years. 3 years without any on-site events. So thank you so much for being here with us throughout the week. Our next event for 2023, instead of doing that in October, we anticipated this event at this time, which usually is in December, but we anticipated due to the Football World Cup. But next year we are going to go back to the first week of December. That is going to be from 4th to 8th of December. Once again, thank you so much. And I hope you took the best of it. Enjoy the rest of your evening. Goodbye.